This is learning target 8.1, so we're going to grab our notebooks and I'm going to teach you the best I can from my house. So starting with 8.1, it's called relations and functions. So I'm going to have you start by putting that in your notes. 8.1, relations and functions. And what we're going to talk about is what these things are, how to identify parts in your ordered pairs, and all the vocabulary that goes along with it. Okay? I want to start with the word relations. So we're going to define that first. What is a relation in math? A relation is just a set of ordered pairs. And we worked with ordered pairs before when you graph. So when you see a list of ordered pairs or a set, it's called a relation. And it's important to remember that when you do ordered pairs, you write them in parentheses. You use two numbers separated by a comma, and X is always first, Y is always second in an ordered pair. So that's all a relation is. It's a set of ordered pairs. This would be an example of what a relation would look like. So I want you to put this one in your notes. Now notice they started with these solution set. And they put ordered pairs in the middle. Now I happen to have 4 ordered pairs, 0, 1, 1, 2, 1, 5, and 2, 6. This whole thing is a relation. Now if I'm going too fast, just hit pause so you can get everything in your notes. Now I could have given you an example like this, starting with my solution set. I could have said 3, 4 and 10, 15. Close it with my solution set. That is also a relation. I could have given you an example like this with my solution set. 3, 4. Close my solution set. That's a relation too. These are all examples of relations. It doesn't matter how many ordered pairs are in the middle of your solution set. A relation is simply a set of ordered pairs. No matter how many, few or a lot, it's still a relation. Okay, so I'm going to go back to this relation I started with. Okay, so some vocabulary words that we need to learn. I'm going to start with the word domain. A domain is your x values. Your domain are all of your x values. Okay? It's the set of all the inputs. And I'll explain inputs in a second. So when I look at this relation right here, and I ask you, what is the domain? Well, I'm looking for all the x's. So in this ordered pair, I'm going to highlight my x value. My x value. I'm going to keep going until I get all of my x values highlighted. That's my domain. So when I write the answer, I'm going to use that solution set. My x values are 0, 1. I'm not going to write the number 1 twice. I'm just going to put it in here one time. And then a 2. And I'm going to close it with a solution set. That's how you write the domain. You just copy all of the x values down right here. You're done. Now I said something about the input. An input is each number in the domain. So that just means that the number 0 is an input. The number 1 is an input. The number 2 is an input. So if I ask you for an input, you can just say 1. I don't have to say that. If I ask you for an input, somebody else might say 2 is an input. An input is each number in the domain. Your other set of vocabulary words, I'm going to start with range. Range is your y. Your range is your y values, or the set of all the outputs. Okay? So if I go back up to your relation up here and look for all the y's or the range, I'm going to highlight all of my y values in yellow. So since there's 4 ordered pairs, I'm going to highlight 4 numbers. If I ask you to write your answer for the range, I'm going to start with a solution set, and I'm going to write them all down, starting with the number 1. There's 1, there's 2, 5, and 6. And then I'm going to close my solution set. That's how you list your range. Now we said there's something here about outputs. Your output is each number in the range. So one of my outputs here is 2. That's an output. Well, maybe I don't want to write 2. I could have also said an output would be 6. Outputs are your Y's. Inputs are your X's. So to keep this straight, remember, domain is the X, range is the Y. I just think alphabetically, D comes before R, just like X comes before Y. That's how I keep them separated. Domain is X, range is Y. So let's try this out. Here I gave you a completely new relation, and the reason this is called a relation is because you see a solution set with ordered pairs. I just so happen to pick 4 again. So question number 1, find the domain of this relation. Now remember, domain is my X values. So I'm going to look up here and I'm going to highlight all of my X's. 2, 3, and 5. Those are my X's. So in order to write my answer correctly, I'm going to start with solution set and list these. 1, then I'm going to do 2, then 3, and then 5, and then I'm going to close my solution set. That's my domain. The next question asks for your range. So I'm going to do range next. Remember, range is my Y value. So I'm looking for my Y's. So I'm going to highlight my Y's. So Y, 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 Y. When writing my answer, I'm going to use that solution set and copy my numbers. So 4, 5, 6, and 9, and then close your solution set. That's how you do your domain and range. Now your first couple of problems in your homework today are just going to ask for you to write the domain and the range. More vocabulary for you. Function. What's a function? That was part of our beginning learning target. What's a relation? What's a function? So a function is a relation. Now remember, a relation is a solution set with ordered pairs. It's a relationship with the property that each input, remember inputs are your X's, there is exactly one output. That's a big deal. Now remember, inputs are your X's, outputs are your Y's. So for every input, there can only be one output. In other words, make sure your X values do not repeat. And I'll explain how to check for that. Now you check for that in 2 ways. These are 2 ways, and I'm going to show you this one first. We're going to check first by using what's called a mapping diagram. Now a mapping diagram is going to be kind of like a Venn diagram, but we're going to use the domain, which is your X's, and the range, which is your Y values, to see if it's actually a function. Okay, here is my first relation. I have ordered pairs, so this is called a relation. It asks us to represent this relation above as a mapping diagram. So I'm starting with the words domain, and I actually write those down, and I'm going to write the word range. Now remember, domain is your x's. So I'm going to look at my x's here. I'm going to highlight them again. This is my domain. Okay. Now I'm going to write those underneath my domain. So 0, 1. Remember, I'm not going to write this both times. I'm just going to write it once. And a 2. And I'm going to circle those. That's my group. That's my domain. Over here, I have my range. And I'm going to go through my relation, and I'm going to highlight my y's, my range. So all of my y's I'm going to make blue. And then I'm going to go down below and I'm going to write those. So starting with 1, 2, 5, and 6. And I'm going to put a circle around those. That's my range group. Okay, so I've started mapping out my information. Finally, I'm going to match these up with lines. So 0 goes with 1. So 0 goes to 1. And then I'm going to match up 1 with 2. So 1 goes with 2. Third one says 1 goes with 5. So go back to this and I draw a line to 5. And my last ordered pair is 2 goes with 6. So 2 and 6. Okay. Now, if I go back, it says a function is a relation with a property that for each x, there is exactly one y. There's one line here. There's one line here. The problem is right here. There's a 1, but you have it going to 2 numbers. You can't do that in a function. It says for each x, there is exactly one y. Well, here's my x, but it has 2 y's. So because of this right here, if I ask you, is this a function? Your answer is no. It is not a function. Why? Right here. It's because your input of 1 has 2 outputs. You can't have that because by definition it says for each x there is exactly one y. So this relation up here is not a function. What about this one? Here's your relation. I have 4 points. I'm going to represent this relation above as a mapping diagram. So remember, this is like a Venn diagram. So I start with the word domain and range. I'm going to write both of those. Now remember, domain is your x. So I'm going to find all my x's. And that's what I'm going to write here. So starting with 1, 2, 3, and 5. Moving over to my range. Remember, range is your y. So I'm going to highlight all of my y's. And that's what I'm going to list under my range. This is a lot easier on the whiteboard than it is on the computer. Okay, Now I'm going to circle these into my groups, my domain group and my range group. Okay, what did we do next? We drew lines from my inputs to my outputs. So 1 goes with 4, 2 goes with 5. Yes, you need to draw these lines. 3 goes with 6, and 5 goes with 9. Okay, so I have to determine, is this a function? Remember, function says for each x, there is exactly one y. One line, one line, one line, one line. Is this a function? Yes, this is a function because each x or each input has only one output or y value. So yes, this one is a function. Okay, the other way to test besides a mapping diagram is called a vertical line test. And in order to do a vertical line test, you need graph paper. Now let's write this down first. A vertical line test means if you can find a vertical line, now remember, vertical lines go this way, up and down. It's like your vertical jump. A vertical line test that passes through more than one point of a graph of relation is not a function. A vertical line test means if you can find a vertical line that passes through more than one point on your graph, that's not a function. And here's an example. This is the same set of numbers we did before, okay? Now what we're going to do first is we're going to actually graph these on a number line, okay? So 0, 1, you start at 0 and you go nowhere, and then you go up 1. You put a point there, okay? 1, 2, start at the origin, over 1, up 2, plot your point, done. 1, 5, start at your origin, over 1, up 5. And the last point is 2, 6 at the origin over 2 and up 6. Okay, so the first thing we did is we put our 4 points on a coordinate grid for this relation. Okay, vertical line test states, draw a vertical line, that means up and down. If it passes through more than one point on this graph, it is not a function. So if I draw a line right here, you can't hardly see it, but it only hit this line, this point right here. If I draw a line up and down or vertically this way, up and down, you'll notice right here and right here, I actually hit 2 points on one line. If I hit 2 points on one line, is this a function? No. Why? Because when I drew a vertical line, I'll move this here. It passed through 2 points. And they're right here. It hit 2 of them. I tried this one, it was fine. I could have tried this one, it would have been fine, but when I tried this one, I would have hit 2 lines. So I tried them all, I hit 2 of them, it's not a function. Here's another example. This is a relation right here. I have 4 points. So the first thing we're going to do is we're going to graph these points. So 1, 4, right 1, up 4. There's my point. I got that one. 2, 5, right 2, up 5. There's a point. 3, 6, over 3, up 6. And the last one is 5, 9, which I'll do my best to put on my graph. 7, 8, 9. Okay, so I got all my points. So I'm going to do that vertical line test. I'm going to pull my line out and I'm going to see if I can hit 2 points at the same time. That one hit 1. I only hit 1. I still only hit 1. Still, no matter what I did, I could only hit 1 at a time. So, is this a function? Yes, it is. Because my vertical lines only hit 1 point. So, this is a function. Now, some of you might find the vertical line test easy to explain if something's a function. Some of you might prefer not drawing on a grid and just making the mapping diagram. Maybe you'd rather do it this way to decide if it's a function or not. Either way is fine. It's just two different strategies to solve these. So here's a couple examples. This is a XY chart like we studied with our Iowa Basic Skills test this week. Remember, these are all ordered pairs. They're just written in a different form. So this is a relation. What are the domain values? Remember, domain is your x values. So what are your x's? Well, your x is right there. These are your x values. So what is the domain? You're going to write down all your x's with a solution set. They are 5, 10, 15, 20, and 25. Close your solution set. Next one, I have my relation down on the bottom this time. Is it a relation? Well, do you see ordered pairs? If you see ordered pairs, yes, this is a relation. I'm going to skip this one because I need to do this first. What is the domain? Remember, domain is your x's. So I need to go down here and find my x's. I'm going to highlight those green. So what is my domain? With a solution set, my domain is -3, -2, 1, and 2. And I'm going to close my solution set. What is my range? Remember, range is your y's. So I'm going to go highlight all of my y values. Those negatives count. Okay, so I need to write down all of my y's. Starting with my solution set, they are 2, -2, 1, -3. Close your solution set. Is this a function? Well, since there's a graph here, I'm going to graph these. Starting with -3, 2, -3, 2, -2, -2, 1, 1, and 2, -3. Okay, this is called the vertical line test. So I'm going to grab my line here and I'm going to put vertical lines through these. I only hit 1. I only hit 1. I only hit 1. I only hit 1. Is this a function? Yes, because my vertical line only hit 1 point, so that is a function. Here's a new relation. This one's pretty long. I have 5 points here. What is the domain? Remember, domain is your x. So I'm going to highlight all of my x's here. So my domain in a solution set is -5, -3, -1, -2, and 5. Close your solution set. What is your range? Remember, your range is your y's. So I need all of my y's here. Make them all blue. to answer my range in a solution set, 2, -1, 0, 3, and 4. Close your solution set. Is this a function? Well, I didn't give you graph paper, so I'm going to do what's called a mapping diagram. My words are domain and range. And I'm going to copy these numbers up here down below. -5, -3, -1, -2, 5. That's my domain group. And then I have a range group. I'm going to copy my range right here. 2, -1, 0, 3, and 4. And that is my range group. My last step is to match these up. So -5 goes with 2, -3 goes with -1, -1 goes with 0, -2 goes with 3, and 5 goes with 4. I just have to ask myself, does each x have only one y? Yes. So is this a function? Yes, because each input for x has only one output for y. Another example, here's a smaller relation. It only has 3 ordered pairs, but it's still a relation. So D stands for domain. Domains are x. So x, x, x. What is my domain in a solution set? I'm going to write my x's, 5, 2, and 1. Close your solution set. My range is my x's, or my y's. Hopefully I said x's up here. These are y's. So these are my y's in blue. So my range in a solution set, 1, but I'm not going to keep writing 1s all the time, so I'm just going to put it like that and close my solution set. Now, is this a function? With this graph, they want me to do the vertical line test, so I'm going to go ahead and plot these points. 5, 1 over 5 up 1, 2, 1 over 2 up 1, and then 3, 1 over 3 up 1. Now I'm going to pull out my line and put my vertical lines in. I only hit 1 point, 1 point, 1 point. Is this a function? Yes, it is. And that is because when I drew my vertical lines, they only hit 1 point. All of them. None of them hit more than 1. So that's why it's a function. I believe this is my last example. Here I have a relation with 4 ordered pairs. Remember again, your domain is your x. So x, 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 x. So my domain in a solution set is 2, 5, 2, oops, I already wrote 2, and 4. Close your solution set. Your range is your y. These are my y's. So to write my answer in a solution set, my y's are 8. I already have 8, -2, and -3. Let's close my solution set. Is this a function? Now you need to decide. If you'd rather use a graph to test this out, that's fine. I don't have a graph here, so I'm going to do my mapping diagram. So domain and range. I'm going to copy these numbers down. So I have 2, 5, 4. That's my domain group. And then I have 8, -2, and -3. And that is my range group. Now I'm going to start drawing my lines. Back up here. 2 goes with 8. 2 with 8. 5 with 8. So 5 goes with 8. 2 with -2. 2 with -2. And 4 goes with -3. Now, as long as one x goes with only one y, it's a function. Here's the problem. 2 goes with 8 and -2. You can't have that. So here's the problem right here. You can only have one x with one y. This x has 2 of them right here and right here. So is this a function? No, because 2 is matched with both 8 and 2. It has 2 outputs, so that is not a function. Homework for tomorrow is right here. You're gonna need graph paper, so make sure you grab a piece of graph paper. That is for your vertical line test. Good luck.